The second lesson in this conics unit is on ellipses. Before we look at ellipses, let's just think about what an oval is, so we don't get these confused. An oval is any curve that looks like an egg or a squash circle. You're an oval, you're an oval, you're an oval. Okay, look like a squash circle. An ellipse is a special oval, okay, which follows a specific mathematical relationship. This is an oval. Correction, this is an ellipse. This is not an ellipse. This is not an ellipse. So all ellipses are ovals, but ovals aren't necessarily ellipses unless they satisfy this relationship. Okay, so an ellipse is a curve such that the sum of the distances to the two focal points is constant for every point on the curve. So what that means is if I have a point on the curve here and I measure D1 and D2, I'll get some value. If I do the same thing down here at this point, measure these 2 points, I'll get the same value. Okay, that's how the construction of the ellipse works. We'll do an activity in class where we'll actually construct some ellipses with pins and string. The other thing about an ellipse is these two focal points are the same distance away from the center of the ellipse. Might need that later on. And we've got a general formula for the ellipse. So the center of the ellipse is HK. And we've got these things called semi-minor and semi-major axes. So the semi-major axis is A. So it's just missing underneath here is A. And the semi-minor axis is B. Alright, so this is formula. Let's just make sure this formula works. I've got a ellipse I want to plot that satisfies this equation. So what I'm predicting is since the a squared value equals 4, you can see how these correspond. I'm expecting the semi-major axis to be 2. Since b squared equals 9, I'm expecting the semi-minor axis to be 3. And since in here I'm not subtracting anything, I'm expecting the center to be at 0, 0. So I'll substitute in some points and see how this works. I'll substitute in the point x equals 0 just to show you, I guess, the full process. So I'll sub in x equals 0 into x squared on 4 plus y squared on 9 equals 1. Wherever I see x, I'll write 0. 0 squared on 4, well, that's 0. I don't need to write the 0. I can multiply both sides by 9. And then take the plus or minus square root. So for x equals 0, I had two solutions, plus or minus 3. Go ahead and substitute in the other values. I'll give you a few seconds to do that. Press pause. There's the points. Probably would have been nicer to have some more points, but we don't have lots of time. And then we can go ahead and connect these to make an ellipse. So connect the points together, mark your axes, and write the equation under there. So let's see how our prediction went. So I predicted the center would be 0, 0. That looks like it's in the center. Predicted a semi-major axis of 2, which means from the center there should be 2 in both directions. Looks good. And predicted a semi-minor axis of 3. So yeah, up 3, down 3 to the extremes. Okay, so this formula does work. Remember, this is plotting. Now that we know that this formula works, we can use our understanding of the formula to instead sketch these ellipses. So part A, I've got this equation. I see that a squared equals 16. So a equals 4, which is my semi-major axis, so my horizontal axis. I see that b squared equals 25, so b equals 5, which is my semi-minor axis, my vertical axis. And I don't see any h or k values subtracted from the x's, so my center again is going to be at 0, 0. So I'll mark the center. Need to go horizontally 4 in both directions, and then vertically 5 in both directions. And now I can connect these to make an ellipse. There's my ellipse. Looks different to the previous ellipse, and in the next lesson when we look at eccentricity, we'll look at different ways that we can classify how squashed or stretched out or whatever an ellipse is. Okay, I'll have a go at sketching this second one. I better write my formula down beside it so I can use it to compare. So I see I've got an a squared value of 4. So my semi-major axis will be 4. Correction 2. See a b squared value of 9. So my semi-minor axis will be 3. Vertically. I see I'm subtracting 1 here, so my h value is 1. I see I'm adding 2 here, so my k value must have been -2, which means I've got a center of 1, -2. So I'll go ahead and plot all this information on. So at 1, -2 is where I'll have my center. I need to go horizontally 2 in each direction. Oops, 2. And need to go vertically 3 in each direction. Make sure you write the equation of the ellipse on here as well. And label your axes. Okay, so from here, your job is to practice this. So either sketching the ellipse or writing the equation of those ellipses that are there. If you get really stuck, and only if you get really stuck, there's some solutions here. Okay, in the next lesson, we'll look at eccentricity in a lot more detail.